In this video, we'll take a look at logistic regression, but doing so with a neural network mindset. We'll start off by asking what is logistic regression. Then we'll go to code, load and prepare some data, and then build a logistic regression model in Keras. Then we'll go through a training and validation step to see how accurate our model actually is. So what is logistic regression? Well, it's actually not a regression at all, it's a classifier. And logistic regression is equivalent to a one-layer deep neural network, which we'll typically use to turn final outputs into the output classes with a softmax activation. So getting a feel for logistic regression as a very simple model is actually a basic building block that we'll end up using in a wide array of classifier neural networks later on, so it's important to understand this as a fundamental concept. So now we can dive into some code, and we're going to be using both scikit-learn and Keras in order to get this done. And we're going to use a classic data set that's all about adult incomes, and there's a link to it here in the notebook. Fortunately, this is already pre-processed into a machine learning usable format with categories expressed as 0 or 1 flags, and all of the individual features encoded as 0s and 1s. And scikit-learn fortunately has a feature in order to be able to open this kind of data file format, this SVM light file. This is actually a standard file format that you'll work with a lot, and it's incredibly convenient that we can get data in this format on the internet. So we'll go ahead and load up the SVM light file that we just downloaded to get the features and the labels. So you can see right away the features have a shape, 1605 samples with 119 variables. And let's take a look at some of these as a dense array. You can see right away that all of the features we have are essentially Boolean flags. It's 0s or 1s indicating if a particular attribute is present on a certain sample. And now let's look at the labels. We'll take a look at the first 10 labels here. And you can actually see this is a two-class output model. It just has 0s or 1s. Now our features are all set on the range 0 to 1 binary, but we need to transform the output labels to one-hot classes, so there can be two distinct outputs, the 0 class and the 1 class. So we'll go ahead and use Keras to turn to categorical those labels and have the output. So you can see here the 1 is in the 0 position or it's in the 1 position, and this gives us a one-hot encoding of our flat array of labels from before. We can go ahead and build an incredibly simple neural network model. We're going to use Keras model sequential to start off our model, and then we're going to add exactly one layer, a dense activation layer that goes from the shape of the one-hot levels in the 1 position, meaning it has two array slots for 0 or 1. We're going to use the softmax activation, and the input shape is going to be the same shape as the features in the 1 dimension, which is our 119 different attribute flags from before. So what we're going to do is turn those attribute flags via softmax, which turns that into a set of probabilities distributed across our 0 case and our 1 case. We're going to compile it with the Atom optimizer using the loss of categorical cross-entropy, which is the loss function you want to use when you're computing classes. And then we'll run for 16 epochs or loops with a batch size of 16 values each time in order to engage in the learning. You can actually see this runs relatively quickly, and the loss comes down from about 0.7 to about 0.3 in short order on each step and each epoch or loop of all 1605 samples. And now we can see how accurate this thing is. So we can actually use the model predict classes across our input feature to come up with a set of predictions. Now we have an array in memory of 0 and 1 flags. And we can actually use scikit-learn to build and get an accuracy score, which is a built-in function that we can use for model evaluation. And we can see that our model is about 84% accurate. Now that's pretty good for a pretty flat model with very few samples. But see how well it does class by class. Is it better at reporting true or is it better at reporting false? And you can actually take a look at this classification report and get a precision and recall score. And so precision is how often is it right, and recall is of all the possible right answers, how many did it get? And so we can actually see it's much better at predicting 0s than it is at predicting 1s, which is actually not surprising because when we looked at our samples before, there were a whole lot more 0s to learn from. Now that was a pretty simple model. And in the next video, we'll actually look at a more sophisticated one, a convolutional neural network for handwriting recognition.